Hi scholars, this presentation is titled Multiple Baseline and Multiple Probe Designs. The two main objectives are to describe the components of multiple baseline designs and to describe the components of multiple probe designs. Let's begin with a review from our last presentation. On the slide is a graph showing a single participant's number of words spoken from 0 to 20 on the ordinate or y-axis. The abscissa or x-axis shows the number of sessions from 1 to 35. 5 baseline sessions are followed by 5 intervention sessions, which are again followed by 5 baseline and then 10 intervention sessions. What is the design? Well, it's an A-B or withdrawal design. Do we see direct intra-participant replication, inter-participant direct replication, or both? This is data for one participant only, so we see direct intra-participant replication. That is, we see the effect demonstrated within one single participant. Finally, is there a functional relation? Well, we need 3 demonstrations of effect at 3 points in time 1. Point in time 1 is when we look at the data patterns from A to B. Point in time 2 is when we look back from B to A. Point in time 3 is A to B. We do see a demonstration of effect because in the A phases, data are low, stable, and when we make the comparison between A and B, we see an immediate level change, no overlap. Then we see the change from B back to A, that same change from high to low, no overlap. From A back to B, data are flat, low, stable. In the B, they're at a higher level, there's no overlap. B is consistently at a higher level than A. So I would call this a clear functional relation for this AB withdrawal design. Now our focus today is multiple baseline and multiple probe designs. This slide shows a graph that reflects the multiple baseline across participants' design. What you'll notice is that this is essentially a set of 3 stacked A-B graphs. That is, the 3 participants, A, B, and C, each participated in a baseline session followed by an intervention session. So we have AB for participant A, AB for participant B, AB for participant C. To make a causal inference or to have the chance to document a functional relation by showing 3 demonstrations of effect at 3 points in time requires that we stagger the introduction of the intervention. So we delay the introduction of the intervention for participant B and C. This allows us to make that A to B comparison at 3 different points in time. Multiple baseline designs use continuous repeated measurement in the baseline phase. In other words, you collect and record data in every single baseline session. This design is useful when behaviors are freely emitted, occurring in free operant conditions. This means the behaviors are not dependent on a schedule. Examples include percentage of trials with correct responses, percentage of communicative responses, number of words read correct. The design is sensitive to the threat of testing. Since testing occurs in every session, students might learn the test and search for the answers. Also, they might experience boredom or fatigue with the repeated testing. Multiple probe designs differ from multiple baseline designs. Specifically, a difference is what happens prior to the introduction of the independent variable. In the multiple probe, the dependent variable is measured on an intermittent basis during the baseline phase. but the multiple baseline uses continuous repeated measurement in the baseline phase. A few rules govern the intermittent data collection in the baseline phase for the multiple probe design. First, a minimum of 2 consecutive and stable data points are needed prior to the introduction of the intervention. 5 are ideal for meeting quality indicators. Also, baseline data are collected across tiers when the intervention is introduced. Both designs are alike in that once the intervention is introduced in its staggered fashion, data are continuously collected. Applications of the multiple baseline or multiple probe can include replication across behaviors, participants, or stimulus conditions and contexts. When we use multiple baseline or multiple probe across behaviors, we can measure the effects of an intervention, for example, explicit instruction or simultaneous prompting, on dependent variables like number of words read correct across word sets. The behaviors under investigation have to be functionally similar, functionally independent to avoid covariance, which could threaten experimental control. In other words, we want to ensure that the introduction of the independent variable to one behavior will not also bring about change in untreated behaviors. When we use multiple baseline or multiple probe across participants, which can be individuals or groups, we plot group data if a group criterion drives the use of a response-guided implementation to the design. Then we display individual data in a table to permit analysis at the individual level. With this design, we want to guard against attrition by ensuring that we have 4 participants or 4 groups as a minimum, so that if one drops out, we can still meet the minimum of 3 demonstrations of effect at 3 points in time to document a functional relation. When implementing multiple baseline or multiple probe across conditions, we evaluate performance in different conditions. For example, individual instruction, small group instruction, whole group instruction, and no instruction, or with different tasks. For example, percentage of intervals with time on task during math, during reading, during science, and during social studies classes. This design is not used commonly, the one across different conditions, because of the challenge with identifying contexts that are functionally independent, yet that allow for the requirement of delaying the intervention in some of the conditions or contexts. On this slide is the graph that shows 3 participants' percentage of trials correct across sessions. The y-axis has a 0 to 100 scale. The x-axis shows sessions from 1 through 15. Though the number of sessions is not visible on this graph, each of the 3 tiers represent a participant where the baseline phase is followed immediately by the intervention phase. Data are collected continuously in the baseline phase. We see no breaks in between the data points. This is continuous measurement. So this design is a multiple baseline across participants. On this slide is a graph where the y-axis ranges from 0 to 100 to represent the percentage of letters in words accurately spelled. The x-axis shows sessions from 0 to 38. The graph has 3 tiers labeled set 1, set 2, set 3. Each tier of the graph depicts baseline data collected intermittently and intervention data collected continuously. What is the design? The design is multiple probe across word sets. So here we see for word set 1, probe 1 is essentially the baseline phase. There are 3 continuous data points. For word set 2, though, we've got 3 continuous baseline data points followed by a break in this baseline probe phase. There are 3 consecutive baseline data points collected before the introduction of the CBI intervention. So we see the staggered effect. I drew the yellow highlight on to illustrate that. With this design, we've got data reported for one participant's performance across 3 word sets. So we see direct intra-participant replication. The intra is within participant replication. Multiple baseline or multiple probe is a good choice when and only when you can meet the criteria of functional independence and functional similarity. When using this design, introduce the intervention only when 3 to 5 baseline data points are stable or moving in a contratherapeutic direction, and the previous tier's intervention data show that the criteria are met. For example, when the first participant moves from A to B, wait for that first participant to reach the criterion during the intervention. For example, 7 intervention sessions completed or 90% correct for 2 consecutive sessions. Before moving to the second participant, before moving that second participant to the intervention. Both designs use continuous repeated measurement. They differ in the data collection during the baseline phase. Multiple baseline, we collect data every session. Multiple probe, we collect data on an intermittent basis, but we still ensure that trend can be detected. Finally, at least 3 tiers are needed to allow for the documentation of a functional relation. Multiple baseline and multiple probe designs have adequate internal validity when all likely threats are controlled for. With this time lag design, the independent variable is introduced in a staggered fashion. This controls for the threats of history, maturation, and testing. With this design, we expect to see change only when the intervention is introduced. Specifically, we look for immediate and abrupt change with no or low overlap between conditions. To document a functional relation, we look for 3 demonstrations of effect at 3 points in time. With multiple baseline or multiple probe, we replicate across tiers to demonstrate experimental control. In what way might we establish external validity with multiple baseline or multiple probe? One way might be to get inter-participant direct replication and include 4 or more individuals or groups as participants. With the multiple baseline or multiple probe design, there are several likely threats to control for. To control for attrition, include a minimum of 4 participants or a minimum of 4 tiers if you're intervening across word sets and or settings. Also, consider incorporating randomization into the design so that the participants can be assigned to tiers at the start date, can be assigned to tiers ahead of time so that the order of intervention can be communicated at the start, and then also a priori decide that range of points when you'll introduce the intervention. This way participants can know how long potentially that baseline phase will last. To control for inconsistent effects, decrease the procedural contrast between conditions. That means change only one thing about the contrast between baseline and intervention. To control for maturation, reduce the session length or reduce the number of response opportunities and reinforce consistently during a condition. Intersperse know-ins, reinforce alternative behavior between trials, for example. Finally, to guard against adaptation threats like the halo effect, conduct history training with materials, formats, trainers, interventionists, or procedures. Finally, to account for the threat of testing, consider using the multiple probe over the multiple baseline design, which will allow for fewer total testing sessions per tier. Since the replication of effects are demonstrated across participants or behaviors or conditions, multiple baseline and multiple probe designs do not require a withdrawal of the intervention. The main advantage here is the ethical appeal of not having to fade an intervention when it's working. Another advantage is that the designs work well with non-reversible behaviors. As educators and allied health professionals, we often implement interventions to address academic and functional skills. These are skills that you can't unlearn. For example, once you learn how to read CVC words, the intervention that helped you do that really can't be faded because you'll retain that skill. We can't withdraw it and expect the behavior to reverse to a baseline level or return to a baseline level. There are limitations to the multiple baseline or multiple probe design. It can be difficult to identify the minimum of 3 functionally independent behaviors. Another drawback is the need to stagger and effectually delay the introduction of the independent variable across participants. This is a challenge, for example, when you're teaching a whole class or working with a small group. You really can't provide that intervention to just one member of the class without sort of drastically changing the environment and condition of learning. Or in the small group, if you only have a 30-minute time slot to deliver a service, it's hard to provide that independent variable to just one member of the group and not have the others exposed to it as well. So it's hard to stagger across individual members of a group or individual members of a class without really creative problem solving. Finally, concurrent monitoring can be cumbersome across participants or behaviors or conditions. It's possible to conduct the multiple baseline or multiple probe in a non-concurrent fashion, meaning that in, say, first semester, you're going to work with participant 1 of your first small group, and then second semester, you'll work with participant 2. That would be introducing the same order of baseline intervention. You'd introduce that stagger or time lag, but the non-concurrent design and delayed implementation is widely critiqued as having weakened internal validity. That is, that critics say that the non-concurrent multiple baseline is really just an A/B design that doesn't control for history or maturation. What do you think? Do you agree? Do you disagree? There are arguments on both sides and valid points to both sides' arguments. To wrap up this presentation, let's walk through the steps of visual analysis. The first thing to do is to ensure that start points for baseline conditions are concurrent. They start at the same time. On this graph, all 3 participants have a data point for session 1, and what we'd want to do is verify that data were collected at the same time, during the same session, on the exact same day and time on the calendar and clock. Let's assume that this holds true. We'd have to read the narrative description to know that. Our next step is to look for sufficiently separate intervention start points. That is, the intervention start points must occur after behavior change is demonstrated in the previous tier. So here participant A is in baseline for 1, 2, 3, 4, 5, 6 sessions. We see a clear separation of data paths when the intervention is introduced. The effect is relatively immediate. There's a jump in this session 6, and the trend continues upward in presumably the direction of improvement for this participant A. But we'd want to make sure that this trend in the intervention is at the criterion level before that intervention is introduced to participant B. So we don't want simply just a 1 session lag without attending to whether participant A's data show a trend in the direction of improvement. Now our task is to do this kind of vertical analysis to determine whether behavior a change occurs when and only when the intervention is introduced. So I'm going to look when participant A meets criterion and intervention, I'm going to look down and make sure that the baseline data for participant B don't also suddenly spike in an increase, showing that maybe there's some other factor influencing the baseline data. I'm going to also look down to make sure that that's true for participant C. So participant C, remaining data points are low and stable, B is low and stable. So vertical analysis is showing that when participant A is introduced to this intervention, participants B and C baseline data are stable. When participant B is introduced to this intervention, and I can see a trend in the direction of improvement, participants C's data are stable as well. So that vertical analysis allows me to inspect at each tier to be sure that the change occurs only when the intervention is introduced. Is there a convincing functional relation? So are there consistent changes between A and B occurring at all tiers? Are the changes abrupt and concurrent with condition changes? The condition change is the solid line break that shows the stagger of the introduction of the independent variable. Do no changes occur in baseline for untreated tiers, concurrent with treatment initiation for other tiers? Is there minimal overlap between adjacent conditions, A and B for all tiers? There is some overlap here. Participant C doesn't really start to show a trend in the direction of improvement until that third intervention session. This could perhaps be explained in the narrative as to what might be happening here that's causing the little bit of delayed effect as the intervention is lagged in its introduction. So I see an immediate change for participant A. I see a little bit of a delayed effect for participant C, a little bit of a delayed effect for participant C, but overall there are 3 demonstrations of effect at 3 points in time on this multiple baseline design graph. We can analyze vertically to see that data during the baseline condition are not stable. This is particularly evident at the end of the baseline condition for participants C and D. So when participant A shifts to intervention, we're kind of looking vertically to see what's happening with the baseline data of the other tiers, the other 3 participants. When participant B moves to intervention, we see a change in the trend for participant C and D. So the vertical analysis is showing us that something else might be happening to influence the trend in the baseline data, and this would weaken the internal validity, the experimental control. When I look at each participant's performance by making comparisons between adjacent conditions, there is overlap between the baseline and intervention for each participant. So there is no evidence, there's insufficient evidence of a convincing functional relation on this multiple baseline design graph. Reflect on your learning with the 2 main objectives. Describe the components of multiple baseline design, describe the components of multiple probe designs. Share the beauty of single case design until we meet again.